Roughly 3 billion years ago, a single-celled photosynthetic bacterium began burping a new chemical that was poisonous to nearly every species on Earth. Over the following hundreds of millions of years, more microorganisms began producing this toxic gas, first saturating Earth's oceans and eventually its atmosphere. Up here, this chemical changed the composition of pre-existing gases so drastically that it caused a global ice age. And the name of this powerful, poisonous, world-changing gas? Oxygen. In the millions of years since the Great Oxygen Catastrophe, most life, including all multicellular organisms, have evolved to rely on this gas. However, there are some places where oxygen-averse microorganisms, like those from Earth's earliest days, have re-emerged. Many of these places are in the ocean depths, beyond the reach of researchers. But there are other bodies of water completely devoid of oxygen, yet close enough to the surface to explore. And one such lake is hidden high in the Swiss Alps' Piora Valley. Formed over 10,000 years ago, Lake Cadagno is one of roughly 200 known meromictic lakes, meaning it's actually two distinct bodies of water stacked on top of each other. The top layer functions like a standard body of fresh water. It's safe for swimming and known mostly for a plump and plentiful fish population that's been the subject of local fishing legends for centuries. But just 13 meters beneath that bounty is a dense, sulfurous, oxygen-free pool, lethal to any multicellular life forms, fish included. In a typical lake, the entire body of water would gradually mix, diffusing oxygen from the surface throughout. But these two layers never mix, as is the case with any meromictic lake. And the reason for this divide in Cadagno is the water's unique chemical compositions. Both layers are fed by rainwater flowing down the mountains. However, this water can take two paths. The first is to trickle down the granitic mountain directly into the top layer. The second is to seep into the Piora Valley's vein of dolomite, a porous rock full of salts such as sulfate. Rainwater that sinks into the dolomite will slowly inch towards the lake, all the while shedding its oxygen and picking up salts. Finally, this heavier water will cascade from sublacustrine springs below the lake's surface, forming the dense, salt-rich bottom layer. This lower layer is anoxic, meaning oxygen-free, and will suffocate any oxygen-dependent life. But it's ideal for the kind of anaerobic bacteria that died off in the Great Oxygen Catastrophe. The flow from the sublacustrine springs creates microenvironments which feed large aggregates of microorganisms that emerge from the lakebed in strange and otherworldly shapes. Various anaerobic microorganisms take in the water's sulfate and emit toxic sulfide. And at the border of these layers, there's a thin blanket mainly composed of pink-bodied Chromatium ocanii, a photosynthesizing bacterium that relies on this sulfur, the way most plants rely on oxygen. However, while neither water nor organisms move between the layers, these ecosystems aren't completely out of touch. Chromatium ocanii live at the top of the bottom layer because they need to be as close to the sun as possible. But while they never cross into the deadly oxygenated waters, they're close enough that organisms like zooplankton can dive down, eat them, and get back up. In fact, this relationship forms the bottom of the upper layer's robust food chain, supporting the lake's legendary fish population. This unique ecology is more than just a boon for Cadagno's fishermen. Having access to an isolated anaerobic ecosystem allows scientists to model the world before the Great Oxygen Catastrophe. For example, when Chromatium ocanii form their blanket, they increase the density of that thin layer of water. As the water sinks, these microorganisms are forced to swim back up, creating a minute mixing of water called bioconvection. This billions of years old phenomenon might be a clue to how early life evolved the ability to swim. And it's just one of the many insights that await researchers studying Cadanho's mysterious depths. Did you know that the largest river on Earth is actually in the sky? Explore the essential waterways known as flying rivers with this video. Or find out what makes the Great Lakes so, well, great with this video.